Alright guys, today we're going to be looking at solving one variable equations. We'll start with something pretty simplistic like the one you see on the screen, 3x minus 5 equals 16. And then we will go through two other examples, one of which we get pretty complicated with some fractional coefficients. So when solving an equation, your goal is to figure out what value of the variable x, right here, makes this true. So we could do this a few different ways. The most probably inefficient ways to guess and check. We could guess, okay, well maybe it's 10, and we could put a 10 in there, 3 times 10 minus 5, and see if it equals 16. So what we want to do instead is we want to look at a way that we can do this algebraically. So an equation has two sides. There's the left side of the equal sign and the right side of the equal sign. So what I'm going to do is I'm going to draw a line down the equal sign just to help me remember that there's two sides, and whatever I do to one side I have to do to the other. When I'm trying to solve for a variable, if I can isolate it or get it alone, I'm going to be able to figure out its value. And so to do that, we basically want to do the inverse operations or undo the things that are being done. So for instance, in this problem, we see that there are two things being done. The x is being multiplied by a 3, and then it is also being subtracted by a 5. And so what we want to do is to undo both of those things. When we undo the things, we do them in the order of operations, but backwards. And so the first thing I'd like to undo is that minus 5, and the inverse operation of subtraction is addition. So I'm going to go ahead and add 5 to this side and add 5 to this side. If you learned how to solve equations with algebra tiles, we called that balancing in. So we balanced in a 5 to both sides so that we can make a 0 pair out of that minus 5 and that plus 5. And so basically the minus 5 and the plus 5 make 0. So then on the left side I'm left with 3x, and on the right side I'm left with 16 plus 5, or 21. From here I need to get rid of that 3, or I need to think about this. If 3 x's get 21, how much do each of the x's get? And so we called that grouping when we were working with algebra tiles, but really the operation that's happening there is multiplication. So to undo that, we will use division. So I will go ahead and divide this side by 3, and I'll divide this side by 3. So this tells me that each x is equal to 7. Now remember, that's the value that makes this equation true, and so a way that we can check it is to basically say, well, if that x is 7, then 3 times 7 gives me 21, and then 21 take away the 5 gives me 16, which gives me a true statement. So I know that the solution x equals 7 is the correct solution that makes this true. All right. For the second example that we're going to look at, you'll notice this one's a little bit more complex. You'll see that we have parentheses where we need to use the distributive property, and we also have variables on both sides of the equal sign. So instead of being able to just undo a few things, we're going to have to rearrange this equation as well to figure out the value that makes this equation true, or the value for x. So just like the last equation, I'm going to start by drawing that line through my equal sign. That line just reminds me that there are two parts, or two sides to this equation. There's a left side and a right side, and whatever I do to one side I have to do to the other. In order to start manipulating this equation, I really do want to get rid of those parentheses, and what this is saying is that I have two groups of 3x minus 4, and then the negative means I have opposite of all of those things. And so if I think about that, if I have two 3x's, I have 6x, but then I have the opposite of that, so that's negative 6x. And if I have two negative 4's, that's negative 8. But if I have the opposite of that, it's a plus 8. The distributive property is really just multiplying. So what I did is I took the negative 2 and I multiplied it by the 3x to get the negative 6x. And I took the negative 2 times the negative 4 to get the positive 8. Now, I don't distribute that negative 2 to anything else because only the things in the parentheses are going to be impacted. So the right side of the equation stays negative 8x plus 10 with no changes needed. At this point in time, I really just need to decide, where do I want to isolate the x's? Since I have x's on both sides of the equation, it's fine if I isolate it to the right side or the left side. It really doesn't matter. And so at this point, you just choose. Regardless, you're going to end up with the same solution if you do your operations correctly. I'm going to go ahead and move all the x's to the left side to isolate the x's on that side, and then move all of those constants to the right side to figure this out. So at this point, I'm going to move this negative 8x to the right side, and so I'll go ahead and balance in a positive 8x to the right side, which means I also have to balance in a positive 8x to the left side. When I make those zero pairs, negative 6x plus an 8x leaves me with 2 positive x's, still the 8 units. On the right side, that negative 8x and that positive 8x make complete zero pairs, and I'm just left with a positive 10. From here, I have 2x plus 8 is equal to 10. I'm going to go ahead and get rid of that plus 8 by balancing in a negative 8 to make those zero pairs. So I will do a minus 8 on this side and a minus 8 on this side to keep it fair and balanced. On the left side, that positive 8 and negative 8 make a complete zero pair, so I'm left with 2x. On this right side, if I have 10 and I take away 8, I'm left with 2. So at this point, I've almost solved because I've almost isolated the x, but at this point I have that 2x is equal to 2, so once again I need to figure out what each x is equal to by grouping, or another way to think about it is dividing. So I'm going to go ahead and divide both sides by 2 to get rid of that multiply by 2. So on the left side, 2x divided by 2 is just x, and on the right side, 2 divided by 2 is 1. So I know that my solution that makes this equation true is x is equal to 1. It's always a good idea to try to see if your solution is correct, and so once again we would just substitute this x for a 1, and so we would take 3 times 1 is 3, and then 3 take away 4 is negative 1, and then negative 1 times negative 2 is 2. So this side of the equation would be 2. I'm hoping the other side, the right side, would also be 2 because that would make this true. So if I put in a 1, negative 8 times 1 is negative 8, and negative 8 plus 10 is going to be that positive 2. And 2 is equal to 2, so I know that this checks out and my solution is in fact x equals 1. Alright guys, for this third and final example that we're going to look at, we went ahead and gave a whole bunch of fractional coefficients, which makes this look a little scary at first, but we're going to handle it just fine. So we have that 2/3 x minus 3/4 is equal to 5/6 x minus 12. And so really the first thing that I would do if I were tackling this problem is I would think, wow, I don't really want to deal with fractions, and so maybe I could do some fraction busters. So I noticed that I have 4 different denominators. I have thirds and fourths and sixths and twelfths, but what they all have in common, a common multiple of all of those, is 12. And so if I were to take 12 of each of these pieces of the equation, I shouldn't have to deal with fractions anymore. So I'm going to take 2/3 x times 12, I'm going to take negative 3/4 times 12, I'm going to take 5/6 times 12, and I'm going to take negative 1/12 times 12 again. So if I take 2/3 x times 12, when I multiply a fraction by a whole number, it's easier if I turn that whole number into a fraction by putting it over 1, because any whole number can be turned into a fraction by putting it over 1, and then I just multiply straight across. So 2 times 12 is 24. And 3 times 1 is 3, so that just becomes 24/3, and 24/3 is just 8, because 24 divided by 3 is 8, so this just becomes 8x. So when I multiply everything by 12, the first thing is 8x. When I take negative 3/4, multiply it by 12, once again I will turn that into 12 over 1 to get a fraction. Multiply straight across, I get negative 36/4, which is just negative 9, because negative 36 divided by 4 is negative 9. I'm going to take the 5/6x and multiply it by 12 as well. So 5/6x times 12, remember once again it's 12 over 1. So 5 times 12 gives us 60, and 6 times 1 gives us 6, and 66 is really just 10, so this part becomes 10x. That last piece of the problem, we're going to take negative 1/12 times 12. So negative 1/12. Oh, and I'm running out of room down there. So think about it this way. If I have 12 1/12, that's really just 1, and so this becomes a minus 1. If you need to see that written out, go ahead and do that so you understand what's going on. From here, this looks like an equation that we've already dealt with, which is really awesome. And so I'm going to go ahead, draw my line again through my equal sign, and I'm just going to go ahead and try to isolate my x's. So once again, I can keep the x's on the left side or the right side. It really doesn't make a difference. I tend to like to keep my x's positive whenever possible. And so I'm going to leave the x's on the right side, and I'm going to go ahead and subtract that 8x from both sides, or balance in a negative 8x. So on the left and on the right, when I balance in a negative 8x on the left side, I get that 0 pair that I was looking for, so I'm left with negative 9, because minus 9 means negative 9. And on the right side, if I take a 10x minus an 8x, I get a 2x, and then I still have the minus 1, or that negative 1 unit. Remember, I'm still trying to isolate the variable even though it's on the right side, so I'm going to go ahead and get rid of that minus 1, and the best way to do that is to balance in a positive 1. So I'm going to add 1 on this side and add 1 on this side. When I make my 0 pairs, negative 9 and a positive 1 leave me with negative 8. And on the right side, a negative 1 and a positive 1 make a complete 0 pair, so I'm left with 2x. So I know that 2x is equal to negative 8, but remember the goal is to figure out what each x is equal to. So to go ahead and get rid of that 2, it is multiplying. I will divide or put it into 2 groups, and I will get that x is equal to negative 4.